Good morning, this is your Stat Sensei, Mr. Spensei, and this is the chi-squared test review, and we're going to go back to scenario one that we're working on in the warm-up. It says, and that is the get a job, a simple random sample. So we had one random sample of 100 high school seniors, so we know we have a sample size of 100. Was selected from a large school district with more than 5,000 seniors. So our population is 5,000. The gender of each student was recorded, and each student was asked the following questions. Have you ever had a part-time job? If you answered yes to the previous question, was your part-time job in the summer only? The responses are below. It says conduct an appropriate statistical test at the 5% level, so alpha equal 0.05, to determine if job experience and gender are independent. So definitely a chi-square test of independence. So we need to go ahead and write what it is that our hypothesis are. So first hypothesis, or our null hypothesis. Remember that the HO always is going to be a positive statement. So job experience and gender are independent. So that's a claim that they are. But remember, if they are independent, we want to add that they are not associated. All right. The ha is a negative statement every single time. So job experience and gender are not independent. All right. So, and if they are not independent, that means there is an association. Remember, consider a dating relationship. If you're independent, that means you're not dating anyone, which means you're not associated with anyone. If you're not independent, that means you are associated with someone because you are dating someone. All right. The expected values. So, first off, we never look at the totals. We only look at the other part of the table that are not including the totals. So when I look at that, I have 1, 2, 3 rows and 1, 2 columns. So this is a 3x2 matrix, and we're going to need to find our expected values. So to do that, we're going to press the second button and enter the matrix, arrow over the word edit, and say that it was a 3x2 matrix. All right. So we input all our values. 21, 31, 15, 13, 12, and 8, which I've already done. Once you have that done, you're going to go ahead and exit. So hit the blue button and then the one next to it. And now we're going to do something that really doesn't seem very logical, but we're going to go ahead and run the test. So stat test. And we're not running a goodness of fit, so we won't be using GOF. We'll be using chi-squared, which is letter C. Observed, expected. We put our observed in A, but our expected will show up in B. We haven't put it there yet. It says calculate. So we end up with a chi-squared value of 2.7102 and a p-value of 0.257. That's a pretty large p-value. So let's go ahead and record that information. So probability that a chi-squared is greater than 2.7102. And we also have a p-value of 0.2579. Up here, they told us the 5% level of significance. So we're going to go ahead and make this decision right now. We don't have to. We could hold off. But 2579 is definitely greater than 500. So our decision is going to be fail to reject. So that's our decision. Also want to talk about the degrees of freedom. Well, our formula is chi-squared, observed minus expected, squared over expected. Well, degrees of freedom is going to be rows minus 1 times columns minus 1. So we have 3 rows and 2 columns. So 3 minus 1 is 2. 2 times 1, well, that just gives us the 2 right here. So our degrees of freedom are 2. And that was also provided to us on the calculator. All right, so we've written down everything important, but we still haven't got to our expected values. So let's go ahead and do that. So second matrix, arrow over to edit. And sure enough, we now have a 3x2 matrix in B. So let me quit out of that real quickly. Second matrix, arrow over to edit, drop down to letter B and press enter. And there we have 24.96, 27.04, etc., as our expected values. So let's go ahead and get those things recorded, because those are pretty important. That's what we're looking for. So 24.96, 13.44, and 9.6. Remember, all of these have to be greater. Every single one of these has to be greater than 5. The observed values do not, but the expected values have to be greater than 5. So make sure you're checking that. And in this case, the smallest one is 9.6, and that's definitely greater than 5. So all are greater than 5. So it's large enough to proceed with this. So random sample. Well, they said that they had a random sample of 100, not 1,000. Scratch that out. Random sample of 100, and that was given. All right. Don't know what happened with my typing. I sure didn't catch it. So in this case, our sample size is 100. 100 times 10 is 1,000, and that's less than 5,000. And remember, they gave us a population size of 5,000. So it's okay to sample without replacement because we're less than 10%. Then we have all expected values are greater than 5. Okay, we need to show our plug. Now remember, when we plug, we only care about the first one, which is this one, and then the last one. Those are the only ones we're going to show. Actually, we care about all of them, but the ones we're going to show are those. And we have, my plug right here is incorrect. I'm going to mark that out because those are wrong. Don't know why they're there. We are going to have 21 minus 24.96 squared over 24.96. So our observed of 21 minus our expected of 24.96 over our expected. And it's always going to be plus dot 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 plus. And then it's going to be my observed of 8 minus my expected of 10.04 squared over 10.04. And that happens to equal the 2.7102. So that's our chi-squared. So that's our plug. Sorry that I had that written wrong, but that's correct now. The observed of 21 minus the expected of 24.96 from up here. The observed of 8 minus the 10.04 over the 10.04 expected. We already said our p-value was 0.2579, and the way we did that, once again, is we entered the matrix and we went stat test, chi-squared, not getting us a fit. 2.710 was our value, but our p statistic is 0.2579. Pretty large p-value. So we're failing to reject. And so our conclusion, the p-value is 0.2579. We fail to reject the null. There is not sufficient, we don't have enough evidence at alpha equal 0.05 to suggest that job experience and gender are not independent. Please remember, this always comes from the restatement of the alternative hypothesis. So let's look at it. Job experience and gender are not independent. Oh, that's what we have. Matter of fact, we said they are associated, and right here, they are associated. Alternatively, you could have said the p-value is 0.2579. We failed to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that job experience and gender are associated. Once again, that's just a restatement of the HA, which means they are not independent. I hope that helps. Hope to see you on the next one. Thanks.